Okay, so now that we've set things up, we're going to get into factoring, which is going to kind of the factoring that people think about when they say, okay, you actually have to factor this equation. So for starters, we're going to kind of introduce the idea. So if you remember foiling, or if you don't remember foiling, we'll just go through a quick example. In order to foil, which is honestly not the best term for it because that's not what I do, but for all intents and purposes, everyone knows what I'm talking about when I say it, or more people know than calling it a double distribution or whatever, is I take my first term multiplied by my first term. I take my first term multiplied by my last term. I just kind of draw these arrows to make sure that I'm multiplying all of my terms correctly. So I'm going to do that a total of 4 times. X times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. I combine like terms to get x squared plus 5x is equal to 6. Now, what factoring is undoing this property. That's the whole goal. Is sometimes it's better to have it in this form, the standard form of x squared plus 5x plus 6. There's a lot of advantages for us to write it in its factored form. So that's the purpose of this section, is to go backwards. And instead of having the x squared, I want to have 2 different binomials in their parentheses, or 2 separate factors. So that's exactly what we're going to do here. Now I have something x squared plus 5x plus 6. Probably already know the answer of what it will look like if I go in reverse, but let's go through the process, and then we have a way to kind of check to make sure the process works. And so I was jumping ahead of it. So in order to factor, generally what our goal is if we have something written in this ax plus bx plus c form, our goal, if there's the a is equal to 1, we get to do kind of the simple form of factoring. And we do that by finding 2 things that multiply to get a c and add to get a b, or vice versa. But generally, it's easier to find 2 things that multiply to get to the constant form than add to the center term, because there's a lot of whole numbers we can add to get 5. There's not that many whole numbers we can multiply to get 6. So that's generally the process. And usually the best way to do it, in all honesty, is kind of guess and check. So we start with saying, okay, I want to find 2 things that multiply to get me 6. 1 and 6 meet that criteria. 1 times 6 is 6, but 1 plus 6 is equal to 7. So that's not going to work, which is perfectly fine. You might guess 5 different solutions before you get to the end result. So instead, okay, let's think of other numbers we can multiply to get a 6. 2 and 3 work. 2 times 3 is 6. And 2 plus 3 is equal to 5. And so to factor this, what we do is we take the 2 parentheses, kind of like we saw in factor by grouping. The first term in each parentheses is going to be x. The second term in each parentheses is going to be the number that we found to multiply c. So in this case, it's a positive 2 and a positive 3. If we have a negative number, like let's say negative 3 was one of our factors, then it would be x minus 3 as opposed to positive 3. So to see another example of this, we have x squared minus 6x plus 8. I kind of pull out a table. You don't always have to pull out a table, but it's a good idea to use to organize your thoughts, especially if this is one of the first time you've ever done factoring. So again, we kind of play this game. I want to find 2 things that multiply to get me 8 and add to get me negative 6. 1 and 8 multiply to get me 8. Sure. 1 plus 8 add to get me 9. So that one doesn't quite work. So let's just try randomly 2 other numbers. 2 times 4 gets me 8, sure. 2 plus 4 gets me 6, which is very close to the right answer, but it's not quite right. I want a negative 6 as opposed to a positive 6. But with this process, I can start to think carefully along the way and recognize that and think, okay, well, I was super close with 2 and 4. Is there anything that I could do to make those numbers get me a negative 6? And in fact, there is. Negative 2 times negative 4 is also positive 8, but negative 2 plus negative 4 is negative 6. So that's a good kind of trick to watch for, is that if the middle term's negative and the last term is positive, it's generally you're going to have kind of to multiply 2 negative numbers, or pick 2 negative numbers. And so to write out the factored form, very similar to the last slide, is going to be x minus 2 times x minus 4. One more before we get into a different type of factoring. Same process here. I want to multiply to get me -24, add to get me -5. So -24 times 1 gets me -24, but that gets me -23. So that's pretty far off from what I want. So it might be a good idea to try and get my numbers a little bit close together. So -3 times 8 gets me -24, and that adds to get me 5. And once again, that's super close to my final answer. The sign's just a little bit off. So maybe what I could do is put a negative on my 8 and a positive on my 3. And in fact, that's exactly what we need to do. That multiplies to get me -24, adds to get me -5, which was the goal. By the way, when you're kind of doing these, if you get to larger numbers like 100 or something like that, sometimes it's good to use a calculator and kind of guess and check and find whole numbers. Because if it's simple factoring and it does actually factor, it's going to be a whole number. So you can just kind of go through your calculator, and in this case it's 24, so you could say, okay, 24 divided by 2 gets me 12. Can I do something with that? No. 3 divided by 24 gets me 8. Can I do something with that? 4 divided by 24. So that's a good way to kind of gather a lot of possible factors for you to kind of look into and see if they actually add to get you your B term, or your B term is always going to be the term next to your X, or your variable to the first power. Now, sometimes we don't have that nice case of having nothing in front of our x squared, and sometimes we can kind of do a very quick fix to remedy that. And this quick fix is built off of the previous lecture of first factoring the GCF. And honestly, that's, if you don't have anything in front of the x squared, that's always should be your first step, is try and pull out the GCF. And so in this case, we have 3x squared minus 15x plus 18. I can't actually factor it using the previous methods, which is kind of known as simple factoring. But I noticed that each of these terms, 3 fits into it. 3 fits into each of these terms. And so once I find that GCF and pull it out, dividing every term by 3, I see that I have 3 times x squared minus 5x plus 6. Now that is something that has nothing in front of my x squared, or kind of an invisible one in front of it. So now we just play the game again. I want to multiply 2 things to get me 6, add to get me -5. 2 times 3 is positive 6, great. 2 plus 3 is 5. Super close, not quite there. So let's try the negative version of each of those. -2 plus -3 gets me -2 times -3 gets me 6. -2 plus -3 gets me -5. And that's what I was looking for. Now it is important when we are just factoring, just straight factoring, to make sure that you bring down that 3. So that's a tiny error that a lot of people make, is we get caught up in the factoring and we think, oh, I got my right answer. I pulled out my 2 things that work are x minus 2 and x minus 3. So those are my factors. But we have to remember that our GCF was 3 originally. And so we need to have a 3 at the end of the problem in front of our factors. Now, this is probably the most complex form of factoring that you are going to see. We call it factor by grouping. So I talked about in the last lecture that the slide that said it was factor by grouping was kind of misleading, because it's only a piece of the puzzle. This is where we're going to put everything together. I think I worked through 2 examples because it is complex, but it's not a bad idea to kind of pause when I get through each step and say, okay, how did he do that? Does that make sense? Okay, that does make sense. Now I can move on to the next part of the slide. So let's get into it. So I have 4x squared minus 13x plus 3. First step, check to see if I can pull out a GCF, because my life will be made a lot easier if that's the case. Unfortunately, nothing fits into -3, 13, and 4 other than 1, but that doesn't really help us a whole lot. So now that we recognize we don't have a GCF, we go into factor by grouping. And so factor by grouping is a notoriously difficult type of factoring. And so if you don't like what I'm showing you, you can go ahead and look online in Khan Academy or Purple Math or something like that. And there's a lot of different ways to do that. What I'm going to show you is honestly not how I learned it, but I really struggled with how I originally learned it. And this is kind of what I've seen the most success with. Okay. So the first step is to multiply your first term by your last term. And now we're going to draw an x, 4 times 3 is 12. We're going to draw an X, and this X is only meant to organize information. So this isn't really a math symbol or anything like that. We're just going to kind of fill it out. And so what we do is we put the two things that or 4 times 3 is equal to 12. We take that and we put it on the top of the X, whatever the first term times the last term is. And on the bottom of the X, what we do is we take whatever's in front of the X term and we put it there. So now would be a good time to pause to make sure that that makes sense to you. My next step is to kind of play that factoring game. And so the factoring game, so you've seen before, is I want to multiply to get the top number, and now I want to add to get the bottom number. So the two things that multiply to get me 12, add to get me -13, are -12 and -1. That one's a little bit tricky, so it might take you a while to kind of find it, but those are the two things that work out. Okay, so now what I do, the whole purpose of that X was kind of to get those two red terms. And what those two red terms allow me to do is they allow me to break up my -13x into two separate things. And so I can actually go into what we saw as factor by grouping in the previous lecture. And so whatever I get as those two sides of my X, I bring one of them and put that in front of an X, so -12x. I bring the other one, put it in front of an X, so -1x. And then I just bring down my first term, 4x squared, that guy didn't change, that's why he's still in black. And bring down 3, that guy doesn't change, he's still in black. Now is a good time to pause again to make sure that makes sense. And now the good news is that once we got past that kind of weird initial step, we're going to do the exact same process that we saw in the last lecture. I'm going to group my first two terms. I'm going to group my last two terms. I'm going to figure out what factor fits into the first two terms. It's 4x. I'm going to divide both of those by 4x and put it in front of those parentheses. So 4x squared divided by 4x gets me x. -12x divided by 4x gets me 3. And then moving on to the second parentheses. And this is, again, something we talked about last lecture. Really, there is no GCF, so you could argue, okay, just put 1 in front of the two parentheses and then go ahead and factor by grouping. But you might notice that if you do that, then you're not going to match up your parentheses. So in order to get your two factors or your two parentheses to match up, you're going to have to pull out a -1 instead. And so if you pull out a -1, -1x minus, or -1x divided by -1 gets you positive x. +3 divided by -1 gets you -3. And so now both of those factors match. And again, that's a super good check when you're going through this kind of complicated process of making sure that you are actually doing it correctly. If these two factors do not match, you did something wrong above. You maybe didn't make your x correctly, or maybe you didn't pick the correct factor out of each of the two groups. But if they do match up, there's a very good chance you did it correctly. So now what I do is I just look at the things that are in front of the groups that match. That's one of my factors. And then the other factor is the two groups that actually match. So I'm left with 4x minus 1 times x minus 3 as my final answer. Let's do one more example. I believe one more. Again, so now we notice that there's something in front of my x squared, so I can't do simple factoring. And instead, I try and figure out, is there something I can do to make it so that I can pull out a GCF? And again, unfortunately, or I guess fortunate for me since I'm doing the example for you guys, there isn't anything that fits into all of those terms. The only factor of 2 is 2 and 1, and 2 clearly does not fit into 15 and 11. So the first step, exactly the same as the last slide. I multiply my first term by my last term with the coefficient of my first term by my last term. And so 15 times 2 gets me 30, not 6 times 5. Anyways, what's important is that it is 30, so cool. And so I take that 15 times 2, 30, and I put it on the top of my x, and I take the 11 and put it on the bottom of my x. So now I'll play the game again of simple factoring. I want to find two things that multiply to get me 30, add to get me 11. I see where the 6 and 5 come from. And those two numbers are 6 and 5. 6 times 5 is 30, 6 plus 5 is 11. So now I'm going to rewrite the thing that I'm trying to factor as I bring down my 15x squared. I don't change him. I bring down, or I break up my 11x into the two things that I found in the red on my x, so the big X on the right. And those two things are 6 and 5, so plus 6x plus 5x. And then I bring down my last term, 2. Now, something that's worth mentioning, and this is probably the number one question that comes up on these problems, and it's a very good question, is sometimes people ask, what if I flip the order? What if I did 5 on the left side of my big X and 6 on the right side of my big X? Does that affect my answer? Will I still get the right answer? And oddly enough, the answer is yes. Your process will look a little bit different along the way, but as long as you're going through the steps correctly, you're pulling out the correct GCF of the two groups, you'll get the right answer. So order doesn't really matter. And so now I'm going to group both of my first two terms and my last two terms. In my first two terms, my GCF is 3x. So I pull out my 3x, leaving me behind 5x plus 2. And in my last two terms in this case, again, there is no factor, but there's 1. So I'm going to pull out 1. And the reason why I don't have to make it negative in this case is that when I pull out the 1, I will have matching factors. So I'm good to go. And so then my final factored form is the two terms that are in front, 3x plus 1, and then the two groups that match, 5x plus 2. Moving into factor by substitution. So this problem, if you feel comfortable from what we've done up to this point, this problem is actually solvable without factoring by substitution, albeit it's a little bit more work. You might have to FOIL and then simplify and then go into factoring, but it's doable. What's nice about what I'm going to show you is, 1, it's going to make your life a little bit easier in this case. 2, if you're going on to any mathematics outside of this course, factor by substitution or U substitution is used time and time again to A, make our lives easier, but B, and we'll see this in the next example, sometimes problems are just not solvable without substitution. So this is a very valuable tool in mathematics. And we start with this example because it is that you could solve it both ways. So if you're not sure U substitution works, go ahead and solve it the long way. You'll get the right answer, or the same answer that I get, which will be the right answer. Okay, so looking at this one, this is very close to just a simple factoring problem. The issue is, instead of just having an x squared, I have an x plus 3 squared. And then instead of having my middle term just be x, it's x plus 3. So wouldn't it be nice that if instead of dealing with that x plus 3, we could do something else? And in fact, that's exactly what we're going to do. I'm going to say, let's come up with a variable, u. I'm going to say u is equal to x plus 3. And if I say u is equal to x plus 3, well, I can substitute in my u for both of those terms. And now I have something that's a simple factoring question. I have u squared plus 6u plus 8. And so I want to find two things that multiply to get me 8 and add to get me 6. Well, that's 2 and 4. 2 times 4 gets me 8. 2 plus 4 gets me 6. But the question wasn't asking for me to factor something with a u in it. It was to factor something with an x in it. And so once I'm done factoring, now I just have to plug back in what my u originally was. So I said u is equal to x plus 3. And now I'm going to put back in u is equal to x plus 3. And so once I substitute that back in, I just simplify. 3 plus 2 is 5. 3 plus 4 is 7. And generally how you pick that u is you pick the term that would make it so that when you replace it, it makes your equation nice. Or another way to think about it, if you're looking and you have a trinomial, something like a trinomial, I guess, truthfully, you're going to have generally a constant term. You're going to have that b or something times a group or a binomial or a trinomial or something like that. And then you're going to have something squared. And that something squared, or that something next to your middle term, is going to be what your u is. So hopefully that wasn't a little too complicated, but if I had a different example off the top of my head, let's say x plus 5 squared plus 2 times x plus 5 plus 3, well, then my u is going to be x plus 5. Let's see another example before getting bogged down. So in this case, I can't actually factor this, or at least from what we've seen up to this point, I can't factor it. We've never dealt with x to the 4th. And so that's this is where the u substitution becomes exceptionally powerful. So in this case, I have an x to the 4th minus 5x squared plus 4. And so I want to have an x squared situation, or I guess something squared. It could be a y squared. It doesn't really matter. And now I have my constant term, so I'm probably not going to replace him. But now looking at my middle term, I notice that I have an x squared there, minus 5x squared. And so that's what I'm going to try and pick my u to be. I'm going to take that middle variable in this case, which is x squared, and then if I substitute that u into my equation, my 4 is not going to change. My x squared becomes u, and then my x to the 4th is going to become u squared. And that's because x squared gets me x to the 4th. And now I have a problem that I can factor. I have u squared, I have nothing in front of my u, so it's actually a nice problem to factor. So I just need to find two things that multiply to get me 4, add to get me negative 5. Those two things are negative 4 and negative 1. But that's what my answer would be if I was factoring with u. I was originally factoring with x, and so my final answer should have x in its factors. So I'm going to put x squared back in, and I get x squared minus 4, x squared minus 1, and then I can actually factor those two individual things again. What's two things that multiply to get me negative 4 and add to get me nothing? Well, that's 2 and negative 2. What's two things that add to or multiply to get negative 1, add to get 0? That's negative 1 and 1. So I can go ahead and factor that additional step, and I get that result. And that last little bit was a little bit confusing and quick. I would recommend looking up completing the square, because that is a really kind of neat shortcut to factoring that, again, if you're going beyond this course, will make your life easy because you see this type of factoring a lot. That being said, it is really just simple factoring again. You would find two things that multiply to get the negative 4 in this case, and then since you don't have an x term, that's the same thing to adding to 0, so that's where that comes from. Okay, fully aware this is a little bit of a tricky slide. We'll go through more examples in class. One thing that is worth mentioning about this factoring by substitution is that this is pretty much what you're going to see. You're not going to see something that has like x to the 7th. You're not going to see something that has each term to be something x to the 4th plus x to the 3rd plus x to something weird like that. It's generally going to be either x plus something, and that's going to be what you're getting, or x minus something, and that's what your u is going to be, or u is x squared. So that's all you really need to feel comfortable for the test. I do recall there is a question on the worksheet that's a little bit more challenging, but in general, these are the only forms that you are going to see.